Ever wondered how data mining works? How about the K-means algorithm? Well, let's start with data mining. It's a powerful tool that sifts through massive amounts of information to extract meaningful patterns and trends. Just think about how your favorite online stores seem to know just what you need, or how social media platforms suggest friends you might know. That's data mining in action. Now let's talk about the K-means algorithm. It's a popular method in data mining that groups datasets into subgroups or clusters. It's a bit like organizing a cluttered room where similar items are grouped together. The K in K-means refers to the number of clusters formed. Ready to dive into the world of K-means algorithm? Prepare yourself for an informative journey. So, what exactly is the K-means algorithm and how does it work? To put it simply, the K-means algorithm is a method used to cluster data points into groups, or as we like to call them, clusters. It's a go-to algorithm in machine learning and data mining that helps us find patterns in data that might not be immediately apparent. But let's dive into the details now. The first step in the K-means algorithm is initializing centroids. These are essentially the centers of our clusters, and we start by placing them randomly. Next, we assign each data point to the nearest centroid. How do we measure nearest? Well, we generally use Euclidean distance, but other metrics can also be used depending on the nature of the data. Once all data points are assigned, it's time to recalculate the centroids. We do this by computing the mean of all the data points in each cluster, hence the name K-means. But we're not done yet. We repeat the process of assigning data points to the nearest centroid, and recalculating the centroids until we reach a point where the centroids no longer move. This means our algorithm has converged and our clusters are now stable. This iterative process of assignment and recalculation forms the crux of the K-means algorithm. It's a beautiful dance of mathematics and logic, helping us make sense of vast amounts of data. Sounds simple, right? But there's more to it. Let's delve deeper into the K-means algorithm, shall we? In the realm of data mining, the K-means algorithm stands out as a powerful tool. However, its efficacy is largely dependent on choosing the right number of clusters. This choice is crucial because it directly impacts the quality of your results. Select too few and you may overlook important nuances in your data. Choose too many, and you risk creating clusters that are too specific, obscuring the larger patterns you're trying to find. So, how do we find this elusive right number of clusters? Enter the elbow method, an elegant solution to this problem. The elbow method is a visual way of determining the optimal number of clusters. It involves plotting the explained variation as a function of the number of clusters, and then selecting the elbow of the curve as the number of clusters to use. This elbow essentially represents the point of diminishing returns where adding more clusters doesn't significantly improve the fit. However, keep in mind that the elbow method isn't the ultimate decider. It's more of a guideline. Sometimes the elbow can be unclear or there may be multiple elbows. In these cases, domain knowledge and intuition come into play. So, that's the K-means algorithm in a nutshell. But let's summarize what we've learned. Here are some key points to remember about the K-means algorithm. First, let's not forget that the K-means algorithm is iterative. It's a cycle of assigning data points to clusters and then recalculating the centroids over and over until the clusters no longer change. This iterative process continues until the algorithm reaches a point of convergence. Secondly, selecting the right number of clusters is crucial. Too few clusters and you risk oversimplification, too many, and you may overcomplicate your data. The K in K-means is not arbitrary, but rather a pivotal decision point in the process. Next, remember the elbow method. This technique helps us identify the optimal number of clusters by plotting the variance of data points against the number of clusters. The point where the plot starts to flatten can be considered the elbow, indicating the optimal number of clusters. Lastly, let's appreciate the versatility of the K-means algorithm. It's not just a theoretical concept but a practical tool used widely in various fields. From market segmentation in business, to image segmentation in computer vision, and even anomaly detection in cybersecurity, the applications of the K-means algorithm are vast and varied. And that's a wrap on the K-means algorithm. Keep exploring, keep learning,